All right, welcome to tonight's lesson. So in this lesson, we're going to start with sets. Yeah, so I'm not really sure how far you have gone in class when it comes to learning. Yeah, but I'll try to call one of you after the lesson so that I just find out how far you have gone so that I know the pace I'm supposed to be moving at. Yeah, and then apart from that, I'll also need your module. I also need your module so that I can be getting some examples from the same module. And then I'll also be getting examples from your assignments and the exercises that are in the module. Yeah, because that is the source of all the questions that you're going to have in your exam. Yeah, if you just know how to solve those questions, it's rare for you to fail an exam. All right, so let's quickly begin. So I'm going to start with the definitions of sets. So we'll start looking at the definitions first. Then from there, we'll discuss the set operations and then set algebra. These are the three subtopics that we're going to look at tonight. All right, so let's quickly begin. Yeah, so we'll first start with the definition of a set. It's important to know what a set is even before you begin to solve the questions, because there are questions that will require you to know what a set is for you to solve them. So a set is simply just a collection of well-defined objects. That's the simplest definition of a set, a collection of well-defined objects. So these are some of the definitions that we're going to look at in this slide. And then we'll also have to look at the set operations like the subset, union, intersection, the set difference and complement, then the Venn diagram, and then De Morgan laws. Yeah, so these are the things that we're going to discuss tonight. So like I said, we first start with the definition of a set. So a set is a well-defined collection of distinct objects. So if we have, for instance, we have these, this is an example of some sets. So we have an example there on the screen. So I'm starting from as simple as these things because I know this is the foundation of mathematics. Mathematics, if you don't know the simple things, no matter how good you are at mathematics, if you are solving a question, if you don't know the simplest, the foundation of the same question that you are solving, it becomes difficult for you to arrive to a correct answer. Yeah, that is where you find a person failing even just to solve a fraction. It's because of the same foundations. It means that they did not pay attention when the teacher or the lecturer was teaching their foundations. All right, so these are some of the examples of sets. We can see this is this is a set and it contains countable elements. We have A, B, and C. Then this set here is an interval set. It's called an interval set, and we all know that interval sets are normally infinity sets. So I'm going to explain that as we proceed. Yeah, the day we'll be looking at interval sets. The day we'll be looking at interval sets. I'm going to explain in details what we mean and the reason why we say that interval sets are what? Are infinity. Okay, what is a null set? So a null set is simply just an empty set. So a null set is an empty set. That is just the other name given to an empty set. So an empty set sometimes is denoted by this symbol, and then in other books, it's also denoted by this symbol. So these are the two examples of symbols that a null set can be denoted. Yeah. Then so an empty set, just from the word itself, empty, means that it doesn't contain any elements. All right, so what is a singleton set? So a singleton set is simply just a set that consists of only one element. So a singleton set only contains one element. So if you have a set, for instance, you have set A, which consists of only one element there. Let's say you have 4 in the set. This one is a singleton set because it only has one element. Okay, we proceed. So that is,
Hello.
okay.
Yeah, someone is asking to share the link there. I don't know.
I have already shared the link. They have not seen it because it's already in the group. Okay, I've shared it again. Yeah, so we were talking about a singleton set. So a singleton set is simply just a set that consists of only one element. Okay. So this is an example. It only has the element A there. Okay, we proceed. Let us see how we can represent sets. So sets can be represented in, okay, basically they can be represented in 3 ways. Yeah, so you can represent sets using the set builder notation. And so you can use the set builder notation. And then apart from that, you can also present set using the roster form. You can also present set using the roster form. And then apart from that, you can also present sets using the descriptive form, just describing a set. So these are the basic ways in which you can present a set. Yeah. And then there are also other ways, but these are the 3 main ways we're going to discuss in this session. And I'm sure these are the ones that are going to be, these are the ones that are in your module, because I taught Zambia Open University last semester. So if you're using the same module, even better, yeah. Okay, so a set is denoted by a capital letter. For example, set A, set B. Yeah, so normally when we are writing the name of a set, we use a capital letter. So you don't say set A is equal to, no, use a capital letter to denote a set. So this one is wrong. Use what? A capital letter. Okay. So we quickly begin, rather we quickly continue. Okay, so these are the 3 ways I was talking about. We have the descriptive form where you just describe a set. For instance, the first set there is a set of vowels in the English alphabet. And then we have the set builder notation. Yeah, so the set builder form, we can see here, we says X is such that X is a vowel in the English alphabet. And then the roster form is the one that we list using these brackets. That is the roster form. Okay, so these are also other examples of the same descriptive set builder and roster form. So let's quickly move on. That's why I was saying these things are simple. In case you don't understand anything as I'm explaining, you are free to interrupt me and ask a question. So the most important things that we're going to begin to learn, okay, even these are important because they are part of the exam, but I believe they are simple. So I'm sure everyone is understanding. Okay, so let's look at finite and infinite sets. So if a set is said to be finite when it has countable elements. So if you are able to count the number of elements in a set, let's say if you have set A, then you have A, B, C, D in set A. As long as you are able to count the number of elements, 1, 2, 3, 4, it means that this one is called what? A finite set. And then if you have set B, which consists of 1, 2, 3, 5, as long as you are able to count the number of elements that are in the set, this set is known as what? A finite set. And then what if you have a set which is, let's say for instance C, then it has these kinds of brackets. You have 1, 3. Can you manage to count the numbers that are between 1 and 3, the real numbers between 1 and 3? It's impossible. So these sets, all interval sets, are what? Are infinite sets. All interval sets that are in this format are what? Are infinite. Same as us saying set D is equal to, or it's just the same as this set that I'm going to write. You have, let's say 1, 2, 3, 4. Then you have 3 dots this side. This set, these 3 dots tells us to say the numbers this side keep on going. And what that means is that the numbers go up to what? Positive infinity. And as a result, this one is also what? An infinite set. Yeah, so there are a lot of different infinite sets. Okay, we proceed. So an infinite set is a set that has a finite or countable number. A finite set is a set that has a finite or countable number of elements. And then an infinite set is a set that consists of uncountable number of elements or unlimited. So these are the examples that are here on the screen. So we have the first one here is a finite set because we're able to count the number of elements there. Then the second one there is an infinite because of the 3 dots that are at the end there. They are showing us to say the elements there, they continue up to positive infinity. So a finite set contains countable number of elements, and then an infinite contains uncountable number of elements. You can't manage to count the elements there. So what is a universal set? So a universal set is simply a set that contains all elements in all given sets, including itself. That is a universal set. Yeah, so a universal set is simply just a set which contains all elements or objects of other sets, including its own elements. Yeah. So it is usually denoted by the symbol U. So you find in some books they'll use this symbol. Then some books they'll use capital letter X. Some books they use capital letter E. So all these 3 symbols are used to denote a universal set. Yeah, so we're saying a universal set is a set that contains all elements or objects of other sets, including its own elements. What does that mean? So this last part, which says including its own element, simply means that if you have, let's say, this is a Venn diagram. You have a Venn diagram there, and then we're saying this is a universal set, and then you have maybe, let's say you have 2 sets there. And then you have set A, set B. Then in set A there you have 1, 2, then you have the intersection there, 3, then you have 4, 5, and then you have 6, 7. So a universal set is simply just a set which is going to list everything here, including, it's going to list all the elements of set A and all the elements of set B, including the elements that are outside set A and B. These are the ones that are referred to as its own elements. Yeah, so we can write the universal set here as 1, 2, 3, 4, 5, including its own elements, 6 and 7. Yeah, so that is what is known as a universal set. Let's look at another thing. So these are just examples of universal set. This is just an example rather of a universal set. So in other words, if you've been given, let's say, set A is equal to maybe you have 2. Let me just get these same examples: 2, 4, 6, 8, 10. Then you also have set B, which is 1, 3, 5, 7, 9. The universal set is therefore going to be 1. You get all these elements, you combine them with those elements. Like that. And you put 3 dots at the end to show that the numbers keeps on going. Yeah, so this is going to be our universal set. And because there are 3 dots at the end, it tells us to say it's an infinite set. Yeah, so we move on. What is a power set? Yeah, so what is a power set? A power set is simply just a set that consists of all the subsets of a given set. So for instance, you have set A, let's say set A contains the elements 1 and 2. So a power set, so if we are to find the power set of A, so the power set of A is simply just a set that is going to have the subsets of what? Of set A, all the subsets of set A, including the empty set and the set itself. So the first subset of A that we have is an empty set, then followed by the set itself, which is 1, 2. And then we can also list this alone and that alone. So we're going to have 1, that's the set on its own. Then we also have 2, it's also a set on its own. So this is a power set of A. So this is a power set of A. If, for instance, or if in any way or any case, or you find a question that is asking you to find the number of elements of the power set, in the power set of A, this is simply just given by 2 to the power n. So sometimes they might not show you this symbol. They will not say find the number of elements, but they will just ask you to say find the cardinality of the power set of A. So whenever you hear that sentence or that statement to say find the cardinality of the power set of A, they are simply asking you to find the number of elements that are in the power set of what? Of A. And you simply use 2 to the power n to find the number of sets that are in the power set of A. So for instance, in this set, we only have 2 elements. It means that the value of n is what? Is equal to 2. So the power set or the cardinality of the power set of A, cardinality of the power set of A is simply just going to be what? 2 to the power n. So if it only consists of 2 elements, we then say this will be 2 to the power 2, and then 2 to the power 2 gives us what? 4. So 2 to the power 2 is just the same as 2 times 2, which gives us what? 4. So when you count here, how many elements do we have? 1, 2, 3, 4. So this tells us to say the formula is correct. Okay.
Hello.
So let's proceed.
Hello.
Yes, sir.
Yeah, please, may you just phrase an example again on the power set, like how a question can come? I think there is something I missed out there.
All right. Okay, so let me give an example. So let's say, for instance, you have set A is equal to, okay, let me use another letter. So let's say we have set B. So we have set B is equal to A, B, C. So if they ask you to find the power set of B, the power set of B is simply just a set that contains all the subsets of the set B. So the set that contains all the subsets of set B, including the empty set and the set itself. So the first subset of set B that we have is the empty set. So you can write the empty set there. Then the other set that we have, the other subset of set B is what? The set itself. So we repeat that same set. We have A, B, and C. And then the other set is a set that only contains A. The other set is the set that only contains B. The other set is a set that only contains C. And then the other set is a set that will contain A and B. Then the other set is a set that will contain A and C. And then the other set is the set that will contain what? B and C. So these are the subsets of this set. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements in the power set of set B. So if, for instance, they ask you to find the number of elements in the power set of set B, or sometimes they may not ask you to find the number of elements, they'll just say, find the cardinality. So this is another question. Find the cardinality of the power set of what? Of B. So the cardinality formula is simply just 2 to the power n. So this n, where n represents what? The number of elements in a set. So how many elements do we have in this set B? We have 1, 2, 3. So we put 3 as a power there. And this is going to be equal to 2 times 2 times 2, because it's raised to the power 3, meaning 2 is multiplying itself 3 times. And this is going to be equal to what? 8. So this implies that we have 8 elements in the power set of B. So let's try to count. Let us try to prove if it's true we have 8 elements. We have 1, 2, 3, 4, 5, 6, 7, 8. So it's true. It's true we have 8 elements in the set. In the power set of B. Okay. So that is how we define a power set.
Question there.
Okay.
Yeah, are we writing 8 elements or 8 subsets there?
Yeah, when we say subsets, yeah, whether you say subsets or elements, it's still the same. In this case, only in this case, it's still the same. Because what we have in the set here, there are what? Are subsets. But if we consider this as a set, if we consider this as a set alone, it means that what we have inside the brackets of this set, inside these big brackets of this set, are called what? They are called elements. So they are elements of this set here. Yeah, so in this case, if you say 8 subsets or 8 elements in the power set of B, you still get it correct.
I got it. The issue is that we have a set like the power B. That's the set, the subset of the power subset, the subset or power set of B. So the whole row here is a set. So we count them as elements.
Yes, they are elements.
Thank you.
All right. Okay, so let's look at the definition now that I've explained, and I believe you have understood. So a power set is a set which includes all the subsets, including the empty set and the original set itself. It is also a type of set. So there's also an example here which says if set A is equal to X, Y, and Z is a set, then all its subsets So we have these subsets. We have these subsets of this set. We have x, y, z, x, y, y, z, y, x, z, and then x, y, z as well. And also an empty set are the subsets of this set. So now the set that contains these same subsets here is the one that we call the power set. So this is an example here I gave. Yeah. All right, so let us look at the equality of sets. So how do you know that this set is equal to the other? Or how do you know that this set is equivalent with the other set? So a set
Hello?
is,
Hello?
yes, you have a question?
Yes, I just want you to go back to the previous point. I just want to read and relate with the explanation that you've given.
Okay, it's here. Can we proceed? So here, I think I just forgot to put the big brackets.
Yeah.
Okay.
So can you hear me?
Yeah, I'm getting you.
Okay, thank you. So when we say we want to find the power set of A, that would be like 2 to the power n, is it?
No.
Would be 3 to the power n?
No. The power set of A is this one here. And then the cardinality of the power set of A is the one that we use the formula 2 to the power n. Then this n represents the number of elements in the set A.
Okay.
Yes. So if
So
the cardinality
in this,
is simply just the number of these elements that you have in the power set.
Hello?
Yes.
okay, so that means power set and cardinality is not one and the same thing.
No, they are not the same. They are just similar. Okay, let me say they are on the same. They are all talking about the same thing, except that one is listing the elements, the other one is telling you the number of elements. The power set.
Which one is?
So the power set is showing the elements that are the subsets of A. And then,
okay.
Yes, and then the cardinality is represented by a small letter n in front of this symbol there. Yeah, it's represented by the small letter n there. And then you use this formula, meaning you are trying to find the number of elements that are in this set, which is the power set of A.
Okay.
Yeah.
Just, hello?
Yes, I'm getting you.
Yeah, just there, sir. So does this mean that here we can actually be asked to solve, maybe to give 3 answers, where let's say, for instance, we read the whole statement and then we take that statement as a question, like say the power set is a set which include blah blah blah. We read the whole entire sentence, and then we come down now where there is the power set of A. Can we take that as a question? How can we phrase the question using that statement?
They will ask you to say, given that, or given the set A as X, Y, Z. And then
Okay.
they'll, yeah, this is how it's going to come, and then they'll say find A P of A. So whenever you see this, it means that you have to list a set in this manner. And then B, they'll ask you to say find N P of A. So if you see something like this with the small letter n in front. Let me write it properly. Find NP of A. So if you see anything like this, means that they're asking you to find the number of elements in the power set. So this symbol here, which is the power set of A, is simply just asking you to list a set in this manner, to list the power set in this manner. And then this one is asking you to find the number of elements in the power set, which is simply just given by 2 to the power n. Okay, so we are in the last 1 minute. So in case the link ends, you should join using the same link which is in the group. As soon as it stops, you should join again so that we finish up the remaining part. So in the next session that we're going to start, when this link ends, we're going to start at, we're going to start with equality of sets.